This video is all about circles. When we started circles, we first talked about the different parts of a circle. So we started with the definition of a circle. A circle is a shape with all points the same distance from its center. Meaning if you find its center, no matter which way you go, the distance should be the same. Then we moved over to another part of our circle, which is called circumference. Circumference is the distance around the circle, the part of the edge or the rim, the outside. And when we are talking about circumference, we think about a math problem in how to find circumference, and we are going to use formulas to do so. We have two listed, and this can be found also on our STAR reference material under the circumference circle. It has our circumference equals 2 pi r, or circumference equals pi diameter, and we will get into the details of those in our next video. The next part of our circle that we talked about is diameter. Diameter is the distance across a circle through its center. It must go through the center to be the diameter. It goes from end to end. This is going to be twice the radius because it goes all the way across, and we'll show you what radius is next. Radius is the distance from the center of the circle to any point. So it doesn't necessarily have to go off to the right. I could have drawn it from the center up. I could have drawn it to the center down. I could have just drawn it to the center and off to the right angle. It doesn't matter where it is pointing. All that matters is it goes from the center out to one of the edges. And this is what we were talking about. Notice the radius is half of our diameter. Our diameter went all the way across. Our radius is only half. So why does that matter? Well, if I give you the radius and I say this line, if I measure it with a ruler, it's 2 centimeters. What would be my diameter? Well, all I'd have to do is this is 2 centimeters. If I were to put another one here and that's 2 centimeters, well, that's 4 centimeters total. So radius is half the diameter, and let's go back to diameter, and diameter is twice the radius. So if I have radius, I can do times 2 to get diameter. If I have diameter, I can do divided by 2, or what's half of my number, to find the diameter. To find the radius. So they're kind of go together in that we can bounce from one to the other fairly easily. All we have to remember, radius is half the diameter. Diameter is twice the radius because it goes all the way across. The next part of our circle is the center, and the center is exactly what it sounds like. It's the point right in the middle of the circle. Why that's important is because from the center, any direction that you go should be the same measurement. Again, just like we talked about at the very beginning. They are equally distant in all different directions. And the last thing we're going to talk about is pi, because as we do equations for circles and finding different parts of a circle, pi is going to come into play. Pi is simply the circumference of any circle divided by its diameter. The symbol looks like this. So anytime you see that symbol, you know that it has a value of a number. The value is 3.14. Now most of our questions in class, or many of our questions in class, will round that value to simply 3. So every time we see pi, we're just going to write 3 and know that it's a little bit more. Pi has no exact value because it's a number that never ends. So because the number goes on and on and on, they stopped and rounded these two numbers. Level 1, you will be more responsible for this exact value of 3.14. But as we work, you will see when this is necessary and when the work is just simply going to round it to that 3 value. And what we noticed as we started working with circles And we started playing around with measurements of circumference and diameter and radius. We realized there's an interesting relationship between the three. So when we first started looking at a circle, and this will not be to scale, but we looked at a circle, nor will it be a nice circle, excuse my drawing. But on our computer program, we were looking at this circle, and the computer measured it for us, and it said, okay, my circumference is 18. So that's all the way around, that's circumference. Then we pushed a button and said, okay, let's measure diameter. Diameter, remember, goes all the way across. They said, okay, the diameter is 6. And then we pushed another button because we had another line going over here. And remember, if it's from the center to any edge halfway, half of the diameter, that's our radius. And it said the radius was 3. We looked at another circle. We took this circle, now again on the computer program, I can't do it obviously with the piece of paper, but we brought that circle out and made it a lot bigger. And we got a circumference of 36. And then again, pushed a button and said, okay, what is our diameter? Well, our diameter, they said, was 12. Pushed another button. Our radius changed also. It was 6. So we started really looking at these numbers and saying, okay, is there a relationship between diameter and circumference? Is there a relationship between radius and circumference? We already know diameter is twice our radius because it goes across the circle 2 times the amount that the radius would. We also talked about how radius is half of the diameter because, again, it only goes halfway. But we wanted to see if there was a relationship with the circumference as well. So if we go back to our first circle, we notice 6 and 18. Well, 6 times 3 gives me 18. Then we looked at our radius. 3 times 6 gives me 18. Okay? So at first we're thinking maybe it's a flip-flop of the two. Well, then we go over here and we think, okay, our numbers got bigger. 12 times 3 is 36. There's that times 3 relationship again. Radius is 6. Well, 6 times 6 is 36. There's that times 6 relationship again. So what we then talked about was for every circle, no matter what size, there is a correlation between the diameter and circumference and the radius and circumference. So we started out with a rectangle and then put it into thirds. The top portion is going to represent our circumference. So let's say we flattened out our circle and put our circumference in a flat line. So here's our circumference. That's our big number. Well, what we discovered is every time we have a circumference and then we measure its diameter, the diameter is always a third of the circumference. Simply put, if I were to pull the diameter off that circle and try to wrap it around the outside, the circumference, it would take 3 diameters to make it all the way around. Why is that important? Well, if I have a question and I have the diameter and they ask me for the circumference, it's a simple multiplication problem because I know it takes 3 diameters to equal a circumference. If they give me a circumference and they ask me to get the diameter, well, then I just flip my thinking around and I think, okay, now I have a big number getting smaller. I know I need my big circumference to divide out evenly into these 3, so that's a divide by 3 problem. Or you could say times 1/3. Diameter is a third of the circumference. Well, then we looked at radius and we thought, okay, there is a pattern there as well. I know that half of the diameter is 1 radius. It takes 6 to get my full circumference. Again, why is that important? Well, if I had a question where I had my radius and they asked me for my circumference, I could easily say, okay, I know 6 radius make 1 circumference, so whatever my radius is times 6 will equal my circumference. Okay, so what if I have my circumference, I need to find my radius? Well, again, I split my thinking. I'm going from a big number to small. I know that my circumference has to divide out evenly into all 6 radius, so I know this is a divide 6 to get from circumference to radius. Or I could say that the radius is 1/6 of the circumference. So finding that relationship will allow us to be able to move from circumference to diameter, circumference to radius, quite easily. On the next video, we'll talk more about those formulas that I showed you on your star chart, how to use them, when to use them, and how to find for circumference, how to find for radius, how to find for diameter.